Okay, so last time we were discussing two random variables. So we discussed a few measures of just one random variable, such as expectation, variance, standard deviation, skewness, kurtosis, but there are also a few measures where we have two random variables. So guys, if you have any question, please stop me and ask. So last time we said, let's say we have two random variables. Let's say, so first of all, let us be very clear that random variables are denoted by uppercase letters. Such as X, Y, Z, and so on. Possible outcomes of random variables are denoted. Guys, if you are not asking questions, please turn off your microphone.
You can just mute everyone.
I see. So possible outcomes of random variables are denoted by lowercase letters. For example, x1, x2, and so on, x, whatever, x, and those are possible outcomes of the random variable x. Okay, so last time we said, let's say we have two random variables. One is your letter grade, in eco 4000. At the end of this semester, let's say we only have two possible outcomes. Specifically, pass or fail. Let's say this random variable letter grade in eco 4000 is denoted by x. And clearly there are two possible outcomes. Let's say x equals 1 if you pass the course, and 0 if you fail. Now we said, let's assume there is another random variable, y, which is your letter grade. In, say, in another course, say Finance 3000, let's say that you are taking right now, and y is the random variable because this is the letter grade at the end of the semester. Let's say y again takes only 2 possible outcomes. Y equals 1 if you pass this Finance 3000, and 0 if you fail. So this can be summarized in a probability table that we call joint probability table. So that will have this form. So we have random variable x, right? X takes 2 possible outcomes, and we have random variable y. So here the first possible outcome of x is, say, 1, meaning that you pass equal 4000, and the second possible outcome, as we had above, is 0, that you fail. Same thing here. First possible outcome of y is 1, that you pass, and then the second possible outcome of y is 0. Right? Can you guys tell me, why is this table called joint probability distribution table?
Is it because it's 2 variables involved?
That's why we have joint, right? But why probability distribution table? Because it lists joint probabilities in these inner rectangles and also some probabilities on the outside, right? on the sides. So here you have inside probability that x1 equals 1 and x1 equals 1, that x equals x1, in this case 1, and y equals 1. I had this before, so there's nothing new up until now. This is probability that x equals 0 and y equals 1. Probability that x equals 1 and y equals 0. There is probability that x equals 0 and y equals 0. So these probabilities that I gave you guys are clearly joint probabilities, right? So that's why we call this joint probability distribution table. So, but probabilities on the side are called marginal probabilities. Why? Because, so for example, here we have probability that x equals 1, no matter what is y. Sorry, y equals 1, no matter what is x. Here we have probability that y equals 0, no matter what is x. Here we have probability that x equals 1, no matter what is y. Here we have probability that x equals 0 no matter what is 1. So here we have marginal probabilities. Here also we have marginal probabilities. And inside we have joint probabilities. So these are, okay, let me draw anything, that's okay. Okay, draw. So these are joint probabilities. Whatever you guys see in the circle, those are joint probabilities, right? So these are joint probabilities. Now let's give some numbers, okay? Let's say here we have, let's say this equals 0.20. Let's say this equals 0.10. Then this equals 0.30 because it will be the sum of 0.20 and 0.30. Let's say here is 0.50, then you will have here 0.70 because this will be the sum of the two marginal probabilities when x equals 1. This will be, here you have 1 because probability cannot exceed 1. So then here you will have 0.70 because 0.70 is 1 minus 0.30. Here you have then 0.20 because 0.20 is 0.70 minus 0.50, and then you just sum these two, and they have 0.30, and then when you add 0.70, 0.30, it is 1, so that means that you entered all the probabilities right. Okay? So let's say this is our example. So now we have, we already discussed two new concepts, marginal probabilities. We discussed, sorry, before that we discussed joint probabilities. Right? So the example is, for example, what is the probability that x equals 1, or probability that x equals 0, or probability that y equals 1, or probability that y equals 0. Those are, sorry, these are all marginal, and then the joints clearly are probability that, let's say, x equals 1 and y equals 1, probability that x equals 0 and y equals 1, or probabilities that x equals 1 and y equals 0, probabilities that x equals 0 and y equals 0. Right? Those are joint. So when you have this kind of table, you can directly, so when you have these numbers, these probabilities, you can directly say, you don't need any calculations, just say, see the table and see the table and say what is the joint probabilities, what are the joint probabilities, or what are the marginal probabilities. But there's another concept, specifically conditional probability. So now let me introduce a new concept, conditional probability. An example is probability of X equals xi. This is a general expression, conditional on y equals yj. And the expression, the formula for that is joint probability that x equals xi and y equals yj divided by the marginal probability that y equals yj. And this is a general expression that is also known by Bayes' rule. Now, let me give you an example on that. Let's say let's apply this expression to our example that we have above. Let's say we want to calculate. First of all, if I ask you, what's the probability that you pass equal for 1,000 given or conditional on that you already passed finance 3,000. Guys, are you with me?
Yes.
So if I ask you this question, let's say if I ask you exactly this question, that what's the probability that you pass equal for 1,000, if you know that if you already have the result in finance 3,000, meaning that if you already passed finance 3,000, would you be able to give me that that probability from this table, directly from this table?
Would it be 0.2?
No, because this table, as I already said, this table only lists probabilities that are joint or marginal. We don't have anything about conditional probability here in this table. So in the inner rectangles, we have joint probabilities, and on the sides we have marginal. But here I'm asking, what's the probability that you pass equal for 1,000 once you know that you already passed finance 3,000, right? That's not directly on that table, but we know that from this expression we can apply this expression, the Bayes rule. We can apply this Bayes rule to this question, and we can write that this is the probability that x equals 1 and y equals 1 divided by probability that y equals 1. And then we go to the table. What's the probability that x equals 1 and y equals 1? X equals 1, you are here. Y equals 1, you are here. And you see that probabilities that x equals 1 and y equals 1 is 0.20. So we write here 0.20 in the numerator. And then on the denominator, we have probability that y equals 1. Can you tell me what's the probability of y equals 1? 0.3, right? So it's given here. So 2/3. This is approximately 0.67, right? So I should be careful, right? So when you write something, you should be as specific as you can. So this will be approximately 0.67. Guys, are you with me?
Professor?
Yes.
So the numerator says probability that x equals 1 and y equals 1. So shouldn't you add the two probabilities?
No, we don't add anything because that joint probability is already here. See, do you see that? So this rectangle here gives us probabilities that x equals 1 and comma means and y equals 1.
Okay, so the comma means and. All right.
Comma means and, yes. Now, the exercise that I want you to do is calculate yourselves
Professor, I'm so sorry, I have a question.
Yeah, please go ahead.
So, if I understood right, conditional probability equals joint probability divided to marginal probability?
Exactly.
Okay. Thank
So
you.
that's I'm not sure who was that, but do you see this? In the
Yeah.
numerator you have joint, right?
Yeah.
In the denominator you have marginal. So marginal means that no matter what is, no matter if I failed or if I passed finance 3000, I'm interested in what's the probability that I will pass eco 4000. I don't care about what I did, how I did in finance. I just want to know how I will do in eco 4000. That's what marginal is. But joint is, I'm interested, what's the probability that I will pass finance and I will pass eco 4000. Right? Conditional tells me that what the probabilities that, those are examples, right? So we have a lot of different possibilities, but just to give you an example, here conditional tells me in this particular example, what's the probability that I will pass eco 4000, given that I already know that I already passed finance 3000. That's what it says.
Thank you.
And as you see, it's a ratio of marginal joint over the marginal. So calculate yourselves.
Professor,
Yes.
a question. It might be a little dumb, but why is it that it's y equals yj? Why can't it be yi? Because isn't it both?
Yeah, so that's a very good question.
Does that matter?
Yeah, that's a very good question. But why I'm doing that is that I'm not limiting myself. So it's like if I had, let's say, y equals yi here, then it would be like x equals 1 and y equals 1. Right? So then I would not be, would be disregarding the possibility that y equals something else. Let's say y equals 0.
Oh,
So,
okay.
so when I write, so it's like any x and any y. I don't want to limit myself like to certain x's and certain y's. I want to have all these possibilities. So,
So is I and j standard?
yeah, so this is like, okay, so see, to be more precise here, I clearly is 1 or 2, and j also ranges from 1 to 2. So because we don't have any more outcome, right? We just have 2 outcomes for x, 2 outcomes for y. I'll go back to this, and this will be clear in the future.
But we typically use I and j, right? Like not A and B, per se.
What do you mean by A and B?
Like the alphabets. Like, is it usually I and J or?
Usually I and J is those are standard. So those are like how to say that, number of outcomes, or so this X, Y, A, B, those are possible outcomes, but the order or number of outcomes are usually denoted by I or J. For example, I could be ranging from 1 to 3 if you had 3 outcomes, 3 possible outcomes in X. J could range from 1 to 5 if you had 5 possible outcomes in Y. So let me postpone this for the future, because I mean this will be clear. But you're right. So I and J are standard notations for the number of outcomes or the ordering of the outcome.
Okay, thank you.
So calculate yourselves this. Also probabilities that x equals 0, y equals 0, and the last one, probabilities that x equals 0, conditional that y equals 1. So this will be, like, I will give you this example. I will do this for you guys. So what will I have in the numerator? I will have the joint probability, right? So this will be x equals 0 and y equals 1 divided by probability that y equals 1, right? And you have this in the table because if you go up, probability x equals 0, y equals 1 is what? This, right? So 0.10. So you write here 0.10, and then what's the probability of y equals 1? 0.30. Right? And whatever you get here will be the answer. Now let me introduce. Also, can we calculate?
Professor, just 1 second.
Yeah, sure. Please go ahead.
No, just I want to take a photo.
You want me to
Can
go?
you go up a little bit? Yeah, I don't
Sure.
see the number. Yeah, just 1 second. Thank you. Thank you. I took photo.
Okay. But this will be uploaded on the CUNY Blackboard as well, the link, and then also this class notes. So can you guys help me calculate the expectation of x? This will be x1 times probability that x equals x1 plus x2 times probability that x equals x2, right? This is just the formula that we had before, if you guys remember. So what is the first possible outcome of x? The first possible outcome of x, according to this, is 1. What's the probability that x equals 1? 0.70, right? So here, then you write 1 times 0.70. Then, what's the second possible outcome of x? 0. What's the probability that x equals 0? That's 0.30. So this will be then plus 0 times 0.30. And this will be 0.70. So calculate yourselves expectation of y. This is what we have to do. Now, can we calculate variance of x? This is from the formula that we know. Do you remember this, guys? Xi minus expectation of x squared times probability that x equals xi, where I changes from 1 to, can you tell me? So whoever asked me that question before. So I changes from 1 to 2, right? Because we only have only 2 outcomes, 2 possible outcomes. So the first possible outcome is 1 for x minus, what's the expectation of x? That's the expectation of x, right? 0.70 squared times probability that x equals 1, that is 0.70, plus then the second possible outcome, which is 0 minus outcome of x minus the expectation, 0.70 squared times probability x equals 0, which is 0.70. Whatever you get will be the answer. Now, can we calculate standard deviation of x? That's the notation. So as we know, that's just square root of variance of x. Right? So whatever you get here, you just plug it here, and that's what you get. Now, let me introduce a new concept, which is a conditional expectation. So the expression is the following. So we are interested, what's the expectation of X conditional that Y equals, let's say Y I, or maybe you want Yj, does not really matter. So this is, the formula is sum of xi times probability that x equals xi, conditional that y equals yj, where I changes from 1 to n. Let me give you an example. Let's say we want to see what's the expectation of x when y equals 0. So this is like, it's like I already failed finance 3000 and I want to know what's the expected outcome in eco 4000. So I'm interested, what is my expected outcome in eco 4000 if I know that I already failed in finance 3000? And this formula tells me this. So this will be x1 times probability that x equals x1 conditional that y equals y2 because y2 was failed in finance 3000 before, plus x2 times probability that x equals x2 conditional that y equals y2, and y2, as you know, means fail in finance 3000. So this is x1 is that I pass equal 4000, which is 1 times probability that x equals 1 conditional that y equals 0 plus x2 is 0, 0 times probability that x equals 0 conditional that y equals 0. So, and this equals 1 times, what is probability that x equals 1 conditional y equals 0? That's probability that x equals 1 and y equals 0 divided by probability that y equals 0. And then plus, in this case, this is 0 because you have here 0, right? So, but I will write, this is probability that x equals 0, 0 times probability x equals 0 and y equals 0, divided by probability that y equals 0. And this will be probability x1 and y0, that's x1, y0, that's 0.50. So we will write here 0.50, and then you divide by probability that y equals 0, which is 0.70, right? Whatever you get will be the answer. So guys, let me ask you, as you know, as you clearly see, if I had different numbers for pass and fail for the possible outcomes, then you will have different number here for the expected outcome of x when y equals 0. For example, if instead of 1 and 0 I said, let's say, pass in eco 4000, let's say, is denoted by number 2, and fail in eco 4000 is denoted, say, by number 3. So then it would have, instead of 0 and 1, 1 and 0, it would have 2 and 3. So that would change the answer here. So you need to be very careful when I give you the exercises, but you will have enough practice, so you don't have to worry about it. Just follow the classes, whatever I'm doing, writing, and you will be fine, because I guarantee that you get enough practice. So now let me introduce another concept, which is covariance. Measures linear relationship association between the two variables. And but be aware that covariance says nothing about the causal relationship. This will be covered throughout the course. Now, what's the formula of covariance? Covariance X and Y means covariance between X and Y equals, we have two summations because it's over X and over X and over Y. So this will be Xi minus expectation of X times Yi Yj minus expectation of Y times probability that X equals Xi and Y equals Yj. And you sum over all Xi's, so I changes from 1 to n of X, that's the last X, and J changes from 1 to the last Y, which is n of Y. So clearly I changes from 1 to n of X, and J changes from 1 to n of Y. Let's calculate covariance between X and Y in our previous example.
Professor,
Yes, please.
can you explain what it means when you're taking two summations?
Definitely. Let me copy this and paste it here. I just want to cut this so that I don't have to do everything from the start.
Professor, are we going to have to do all of this manually?
Yes, you will. In Excel, you can do this in Excel.
Oh, so would we have to like memorize formulas or like manually plug in?
Everything will, yeah, everything. And you will see this in the exams too.
Wait, so we have to manually plug it into the formula?
Yeah. So you do this, everything you do. I mean, you do this manually, right? So there are some ready functions in Excel, but and whatever is better for you. But this particular stuff has to be done manually because there's nothing that helps you do this. There's no ready function for this particular type of exercises in Excel.
So you're saying what we're doing today, there's no formula for it, or you're just talking about this chart, or?
Yeah. So there are no formulas for this particular type of it. There's some ready functions in.
Like there's no function for covariance X and Y?
No, there is, but this is something slightly different. So you'll get confused. So I will tell you when you can use Excel. But right now for this is somewhat different type of exercise. But
Okay.
there definitely is functions in Excel for expectation, for variance, standard deviation, covariance. Definitely they are there, but this is a little different type of exercise. We have probabilities here.
Professor, can you just scroll up a little bit?
Yeah, sure.
So would we have to memorize everything?
No, because you definitely need to understand how we are doing all of this. And then, as you know, everything is open book. So, and even if it was not like this online classes, I do give formula sheets to my students. So you don't really need to memorize anything. You just need to know that these formulas are there. You need to know the meanings of these formulas. And also you need to know how to apply those formulas to the questions at hand. You see what I mean?
Yeah.
Professor, before giving like homework, can we do something like from scratch, like the way you are going to ask the question, and so from the start, so we can do like how it's going to like.
So
question, right? So you're
yeah.
going
So don't worry. So as you know, I am already solving some problems, right? So homeworks will be somewhat similar. So as you know, as you say, so I already solved an example of how to find conditional expectation. Above I gave you guys example how to find variance expectation, and also conditional probability. So I did give you some examples, but it's not like the only examples I'm giving. I will have class exercises, but I have to give you homeworks because, I mean, and also as you know, I extend the due dates. I do have class exercises, right? And I will do those in class. And you can try to start doing homeworks. If you have questions, you can ask me, and I will also be doing class exercises. So you don't have to stress, you don't have to worry about anything. Just try to follow as much as you can. Of course, start doing homeworks and ask questions, and I will also be solving additionally exercises in class. These are just examples.
Yeah, okay.
That I'm giving, but this is not the exercises that I'm doing in class. Those are separate, and I will do. But since I will finish today chapter 2, I'm almost done, right? I will give you homework so that you can practice yourselves, and then I will also be doing the exercises in class. So before the midterm, you will have enough exercises. Just try not to fall behind. Try to follow, because the class will get intense, and you need to be on track. And again, if you guys have any questions, you can always reach out. Yes.
Do you provide slides for us?
Yeah, I have slides. Yes, I have slides, but I usually, so whatever I have on slides, I write. So I write the key points from those slides in this blue screen Word document. But the thing is, the slides have nothing else than what I am doing here. But clearly, I think I already uploaded the class slides. So guys, I will, if you let me, I'll keep going, and clearly you can ask questions. So somebody had questions about this I and J, and we need both summations because we are summing over all X, over all the possible outcomes of X. And those possible outcomes are from 1 to n of X. And we are in addition summing up over all outcomes of Y. and the outcomes of y range from 1 to n of y, and n of x is not necessarily equal to n of y, because we may have, let's say, 3 possible outcomes for x, and we may have 5 possible outcomes for y. Now, let's in this example, let's calculate covariance between x and y. So it will be easier if you do this. If you calculate it as I do now, because you will have to add certain stuff. So here we have probability that x equals 0 and y equals 0. This is times probability that x equals 0 and y equals 1 times probability that x equals 1 and y equals 0 times probability that x equals 1 and y equals 1 equal. And then you have to sum this up. This plus that plus this plus that, and you have the answer here. Let me just ask you, do we have any more joint probabilities? Did I list all the joint probabilities here?
Yeah.
Yeah. So according to this formula, right, I will have, what will I have here? I will help you. x1, which is 0, right? Minus expectation of x, 0 minus expectation of x times y equals 0, right? So 0 minus expectation of y. Here x equals again 0, 0 minus expectation of x. Here y equals 1, 1 minus expectation of y. Here x equals 1, 1 minus expectation of x. And here y equals 0, 0 minus expectation of y. Here x equals 1, so 1 minus expectation of x. And here y equals 1, so 1 minus expectation of y. So now, do I know expectation of x? Do I know expectation of y? Yes, because we calculated that before, right? Are you guys with me? Expectation of x. So here, where is this? So guys, here, do you see? We calculated the expectation of x. And also, we did not calculate, but there is the expectation of y as well. So what will be expectation of y here? Expectation of y, I said calculate yourselves, but if you calculate yourselves, you will realize that expectation of y is 0.3. This is 0.3. And I will say check this. Okay. So 0.3 will be here. Here I have 0.7. Here I have 0.3. And so what I have is the following. So instead of this, I think this will be good. Instead of these expressions, I will have 0 minus expectation of x is 0.70 times 0 minus expectation of y 0.30 times what is probability that x equals 0, y equals 0, that's 0.20. And you add this, add to this what? 0 minus 0.70 times 1 minus 0.30 multiplied by probability that x equals 0 and y equals 1. That's 0.10. And you add this, add to this 1 minus 0.70 times 0 minus 0.30 times probability that x equals 1 and y equals 0, which is x equals 1, y equals, which is here 0.50 times 0.50, and then plus finally 1 minus 0.70 times 1 minus 0.30 times probabilities that x equals 1 and y equals 1, which is 0.20. So, and eventually you will get a number. This will be your answer. So that's how we calculate covariance between x and y. And the last concept that I want to introduce is correlation coefficient.
Professor, so basically if there weren't just two, so in this case we only have 0 and 1.
Yes.
So if we have 0, 1, 2, 3, then there would be a lot more lines of those.
That's exactly absolutely right. And you will have to do it in the homework and also in the exam probably, but I don't really give that on the exam because it's too time consuming. So therefore I just have these two possibilities for each variable x and y, but you are absolutely right, because how many possibilities would you have if you had like 3 outcomes for x and 2 outcomes for y?
You'd have 9 joint variables.
6. So for x, if you had like 6 possible outcomes of x, right? So if you had, so I don't want to confuse you guys, but the thing is, okay, if x had 3 possible outcomes, right? So
or y, and there would be 9, right? You're asking if
and y had only 2, right? So y, let's say, how many joint probabilities would you have?
6.
Yeah. Three times 2, right? And so instead of 4, you would have 6 joint probabilities here, and then you would have similarly like additional terms on the other side too. Do you guys agree with me? Right, so.
Sorry, I have one more question.
Yeah, sure.
Expectation of x plus expectation plus y, it's supposed to be 1 always?
No.
No?
No. This is just a coincidence.
Oh.
Coincidence. No. But that's a good observation, but it's not entirely true. So this is a coincidence. Do you see what I mean?
Yes.
Thank you for clarifying, because I think that's important. Correlation coefficient is the ratio of, which is denoted by rho between x and y, is a ratio of covariance between x and y over standard deviation of x times standard deviation of y. Okay? And you know how to calculate standard deviation of x and standard deviation of y, because we did this before, a few pages above, and we just calculated that part. So the numerator, so you can calculate this. Correlation coefficient does not have unit of measurement. And is in the interval from -1 to 1. Large negative numbers negative value means large negative correlation. Large positive number or value means large positive correlation. If rho x and y equals 0, this means there's no correlation between x and y. So this will be like large negative correlation. If you want to depict, if you have x here and y here, would be like this. Large positive correlation would be like this. And no correlation would be like this.
Professor, what is
Yeah.
the max coefficient you can have? Is it 1?
Yeah, I will say that now. If rho x and y equals -1 means perfect negative correlation. Between x and y, and likewise rho xy equals 1 means perfect positive correlation. Okay, that's very good. Now let me guys explain. So we said there are okay, so we said that there are discrete and continuous random variables, right? Can you give me example of continuous random variable? I mean, we already did it, right? So
you said GPA?
yeah, that's true. That's very true. Okay, so for example, your GPA at the end of the course, right? We said this already. Okay, and then, okay, because we have continuous random variables, we have examples of, examples of of, we have numerous, we have a few, we have a number of I'm not sure if I told you this before, number of continuous distributions. And examples are normal. The people start from uniform, normal, and standard normal. Then we have students D. We have chi-square. We have F distribution. We have exponential and others. We will concentrate on normal, standard normal, student T, and depth. That's what we will discuss in this course. And but there's also a number of discrete probability distributions. We also have, as I said, number of discrete probability distributions, and examples of discrete probability distributions are distributions are Bernoulli, probability distribution, second Poisson, and but we will concentrate on, we will just discuss Bernoulli. So Bernoulli random variable takes only two outcomes. We had before. Specifically success, which is denoted by 1, and failure, denoted by 0. Success can be anything. It rains tomorrow. I pass. You go for 1,000. I will start a job next year, and so on, right? So the probability distribution of the Bernoulli random variable is the following. When the variable x, let's say Bernoulli random variable x, right? So x takes only two values. this is my x. It takes only two values, x1, which is 1, success, and x2, which is 0, failure. And here I have probability that x equals x1, xi. Right? So here will be probability that x equals x1, and here will be probability that x equals x2. Probability that x equals x1 is usually denoted by small p, and this will be therefore 1 minus this small p. Now, can we calculate the expectation of a Bernoulli random variable x? This will be 1 times p, right, plus 0 times 1 minus p. So this is p. So the expectation of the Bernoulli random variable x is the probability of success. And can we calculate variance of the Bernoulli random variable x? This will be the sum of xi times probability that x equals xi. I changes from 1 to 2 in this case, right? So this will be then 1 times probability that x equals x1 is p. Sorry, this is not the variance, right? So it's going to be expression. So xi minus expectation of x squared times probability that x equals xi, and I changes from 1 to 2. So then we will have the first possible outcome 1 minus p, because the expectation of x is p squared, times probability that x equals 1 is p, right, plus 0 minus p squared times probability that x equals 0, that's 1 minus p. So this will be then 1 minus p squared times p plus p squared times 1 minus p. So then let's open the brackets. So you can actually you can factor out 1 minus p from both sides, and you will have 1 minus p times p plus p squared, and this will be 1 minus p times p minus p squared plus p squared. So this will cancel out, and then we will have 1 minus p times p. So that's the variance of the Bernoulli random variable. So then the standard deviation of x will be square root of p times 1 minus p for the Bernoulli random variable. So so we completed chapter 2. Today I will assign homeworks, and start working on that. If you have any questions, you can definitely ask me. You can reach out and you can discuss everything that you like to discuss with me. And as I said, even though I gave you a few examples in class, I will definitely have time for class exercises. So for the midterm, you will have enough practice, but I think you can from now on start attempting to solve the problems from chapter 2. So guys, this completes our today's class, and if you have any questions, I'll be very happy to answer. Thank you for being here.
Professor,
Yes.
when is the homework due exactly?
I usually set the due date a week after, but as you know, I am always extending the due dates, so that's not a problem.
Okay, all right. Thank you.
Professor,
Yes,
can you quickly explain again what P equals? What is P representing?
P is just a probability of success that is given, so that's like, that should be given. That P is just probability that X equals 1.
Okay,
Probability
got
of
it. Thank you.
success. Yes.
Professor, one more thing.
Yes.
Can you just please double check on the lecture you posted like 2 days ago or 3 days ago? Because I was trying to watch it over. I didn't get to see the whole video. It's missing like 15 or 10, 15.
I will double check that, but that's what I have from Zoom. I was a little surprised that I mean, so see, I am recording right now. I will turn off the recording, and then in a few hours, maybe in an hour or so, it will be converted into the video, and then I will upload the link. I will put it in my Dropbox and then upload the link on the CUNY Blackboard. That's what I'm doing. So I don't really know why the last 15 minutes was cut. I have no idea, but I will double check that.
Okay, thank you, Professor.
Okay.
Wait up, Professor, I had a question.
Yes, sure.
So for the homework, you said that you're going to be extending the due dates, but how does it work as far as completion? Like, are we given multiple chances to complete it? Do we have to get 100% in order to get credit, or how does the grading for that work?
That's very flexible, so you can try as many times as you can, and also you don't have to have 100%. So whatever percent you have, that will be your grade. So
Okay.
that will count towards the overall course grade.
All right, thank you.
Professor, I was looking online on Blackboard and I couldn't find the slides.
Really? No, it should be on the first. The thing is, check the first 2 folders.
Okay, I'm gonna do that now.
Yeah, please do. Because if I don't have it, I will definitely upload, but it should be there.
The first 2 folders in course documents?
Yes, yes.
Yeah, they're not there. The first folder is class recording, and the second one is statistical tables.
No, let me see, because I remember I did upload it. So let me just double check. Course documents, class recording, statistical, week 1. Do you see this? It is there. So in week 1 folder.
Is it labeled week 1, chapter 1, part of chapter 2?
Exactly. And then in week 2, we will see the continuation of this second chapter. And also there are class notes. Today I will upload these class notes too.
Okay, thank you.
Okay.
Thank you, Professor. Have a good day. Bye. Thank you.
You too, guys. It was very nice to see you. Have a good day, and I hope to see you all on Monday. No, we don't have class on Monday, but in Wednesday's class.
All right. Thank you. Peace.
Bye, guys. Thanks.